Hello and welcome back to Engineering in Motion. In the previous lessons, we transformed a simple ultrasonic setup into a fully functional radar system that the system is capable of detecting, tracking, and visualizing objects in real time. We introduced filtering techniques, motion estimation, and even a physical LED-based feedback system. But despite all these advancements, one critical element was still missing. The system could see, it could analyze, but it couldn't react. In real-world engineering, detection alone is not enough. A system must actively respond to its environment and communicate risk in a clear, immediate, and intuitive way. In this lesson, we take that next step. We introduce a real-time audio warning system, turning our radar into an intelligent, responsive platform. As objects approach, the system will dynamically adjust its behavior, from silence to slow alerts to rapid warnings, providing a natural escalation of urgency. More importantly, we implement this using non-blocking multi-threading, ensuring that our visualization, tracking, and response system operate seamlessly in parallel. This is where our project evolves from a visualization tool into a true interactive system, one that not only understands its environment but reacts to it. So let's begin. The hardware is exactly the same as lesson number 7. So we have, an ultrasonic sensor on pins number 9 and 10. We also have a servo on pin 11. We also have our 8x8 LED matrix on pins 12, 13, and 8, if you can remember. We added in lesson number 7. The Arduino code is identical to lesson number 7. It just, runs the servo, reads the sensor, lights the LED rings, and sends angle distance pairs, okay? Nothing to change there. So everything will just happen today in only Python environment, okay? So now let's open the Python script. This is our Visual Studio Code environment. So I'm gonna open, the lesson number 6 code because, if you can remember, in lesson number 7, we only just updated or changed, the Arduino IDE code. But today, in today's lesson, we want to just, update the Python environment or the Python code. So I'm gonna open the last lesson or lesson number 6 code. This is the code that we created in lesson number 6. So now I'm going to just create a new file for today's project. I'm going to call it, for example, like radar part, so part 7 today. Okay, so part 7 dot py. Okay, so this is the file for today's lesson, and this is for lesson number 6. Okay. So I can easily copy the whole, I have to select all. After select all, I have to copy, and then I can just close this code, the last lesson's, code, and I'm gonna just paste it in our today's file. Okay. So we can just start from beginning and, start updating our code. So for today's project, guys, we need to import, 2 new libraries. Okay, let's just import them, and when we import them, I will just explain to you, what these libraries are or why we have to import these libraries. So the first library, I'm gonna say import, it's called, threading. So the first library is, we said import threading. What is this, threading? Think of threading as a way for your Python script to run multiple tasks at the same time, like, having a dedicated worker for each job. But maybe you're gonna ask why we need this, why we have to import this, threading. The reason that we have to import this threading is because the next library that we want to import That's gonna make, some troubles for us. So in order to solve the troubles that, are generated by the next library, we have to import these threading, okay? So, but what is the next library? Let's import the next library. I'm gonna say import. So now to import the second library, I'm gonna say win sound. So import win sound. So win sound is the next library that we need for today's project, because we want to just make some beep sound or some sound, for example, different kind of sounds for our sensor. For example, when an object approach to sensor in different distances, we need different kind of sounds. So we have to import these win sounds. But I said, we imported the threading because of the win sound, because I said win sound gonna just make some troubles and make some problems for us. Why it makes problems for us? By itself, win sound that beep, that beep is a built-in function in win sound library that we're gonna use it in our program. So, when we use that built-in function, it's a blocking function. So winSound.beep is a blocking function. When you call it, the entire program freezes and waits for the beep to finish playing before moving on to the next line of code. For a short beep, this might not seem, like a big deal. But, for our radar, which needs to constantly read sensor data and update the screen, even, a tiny pause would make the display appear, choppy and unresponsive. But how are we gonna solve this problem? We solve this by giving the audio its own thread. We create a new thread specifically for the, functions that we created with the help of this WinSound library that we imported, which plays, the beep, okay? So this is about, the threading so far, but what is, WinSound? Why we imported WinSound library? WinSound is a built-in Python module that provides a basic interface to the sound playing machinery in Windows. Since it's part of the standard library, Lucky, you don't need to install anything extra. You have to just import it and you can easily just use it in your program. Just be very careful, guys. It's very important. The WinSound module is fantastic for simple beeps, but it has a few just, important limitations to keep in mind. It's only work on Windows, so it's Windows only. It only works on Windows. If you try to run this code on a Mac or Linux computer, it will just fail. You have to use another ways. I don't want to just tell you how you should use or how what you should do, because for now we are just working on Windows, okay? And the other limitation that we have with this is the blocking nature. As we discussed just now earlier, in the threading library, it halts the thread it's running in until the beep finishes, okay? These are two limitations with the WinSound library that we have, but we assume that all of you working on Windows, so that's so we think just everything will be okay and we won't have any problem with this. So let's just go to the next lines. So guys, we don't need to just change anything here because we don't want to just delete anything from the previous lessons, but we just want to add something. So we don't need to change anything here in our initial conditions or our parameters. Everything will be the same. Yes, distol, last time sweep angle, yes. So this is for the variables, or the global variables, initial condition, parameters, or whatever you want to call them. So but today we have to just add some new variables. The new variable that I want to add today, I want to just hold the latest filtered distance and put them in new variable, and later I will update this variable. Okay, so I'm gonna say I'm gonna call it like current distance. Okay, so current distance, and as I told you, I want to hold, the latest filtered distance, and later in the main loop we will update it. So I'm gonna say 100. This is the first variable, and I'm gonna just again introduce a new variable. It's called a running. What is this running? Running is a flag that allows the sound thread to exit clearly when the program ends. Okay, and at the beginning I'm gonna just pass it true. All right, so this is the two new variables that we have that we need for today's project and today's lesson. So just one more time, this current distance, the first variable that we created today, it's a variable that acts as a communication bridge between the main loop and the sound thread. Okay, and the running is the Boolean variable that controls whether the sound thread should continue running or exit. Okay, so this is for the two new variables that we have added to the parameters or the initial conditions of our lesson. Now let's continue. Let's go to our helper function sections. We have classify color, so we don't need to change anything here, guys. And we also have the update objects. We don't change anything here as well. I think so. Yeah, we don't need to change anything. But today, because we want to just add the audible effect, so we have to just add a new function for our beep sound. Okay, so let's create our function. I'm gonna just say def. Let's give it a name like let's say sound worker. Okay, so sound worker, sound worker, open and close parentheses. Okay, this is the name of the function that I want to just use as today's lesson for our audible effect. So what is this sound worker, guys? Let's review one more time. The sound worker function is at the brain of the audio system. It's constantly running in its own thread. It is a continuous loop that reads the shared current distance that we created above. Okay, because this is a global, these two variables that we created today, we want to use them as a global variables, and you already know what is the global and what is the local variable. Global variables means that the variables that we define them outside of the function, but the local variables is the variables that we define them inside of the function. Okay, so it reads the shared current distance and translates it into an audible warning. Okay, so first of all, let's begin. You don't need to pass any argument to this function today. So now let's just first say that current distance and running, these two variables, they are global. How we can do that? I can say global, and I can say current distance and running. Okay, so current distance and running tells this line, I mean global current distance and running, tells the function that these two variables are the global variables defined outside the function, not new local ones. We don't create them inside the function. This allows the function to read the radar data and check the shutdown flag. Okay, now inside of this function, for the first time, inside of the function, we want to just use a while loop. Before that, we always use, if you can see here, we were using the while loops as our main loop and outside of the functions, and we were using the functions inside of our main loop. Okay, but today I want to use a while loop inside of the function, inside of this sound worker function that I created. But what does this while loop, do today? Let me just create it first so you will understand what I am talking about. So while, now I'm gonna say while running, okay? So while, sorry, while running, okay? So while running is true, okay? Sorry. Okay, so while running is true, I don't know why it's running. See guys, I made a mistake here. Thankfully I just because I saw that it doesn't accept it doesn't accept, my variable that I wrote down here. So I said maybe something's wrong. So running, see, I forgot to add an n here. Running. So running, yes. So while running is true, it means this. So why I am using this while loop? While running means this loop will run continuously and generating beeps as long as the running flag is true. Okay, this running, if you can see here, the running we said at the beginning, we said true. So this while loop is just keep running until this flag, this running is true. After that, I can use the if conditions to just tell the program the conditions that I want to hear the beep. For example, I want to say if the current distance will be smaller than whatever you want. For example, smaller than 20, 10, 30, it just completely up to you. I can just, these numbers, you can just alter them, you can change them. So I can, I want to say, for example, current distance, I can just put this current distance instead of just writing the whole thing. Let's first just put this current distance inside of a small a shorter variable, like say let's d. I'm gonna say d means the current distance. Okay, so instead of using current distance, we can easily say d. So d is a variable for current distance. So I can say if d, for example, smaller than 20, now I want to just create this wave sound, and if, for example, d smaller than 50, I'm gonna change the wave sound, and smaller than 80, and up, it's completely, and so far it's up to you. So let's create our if conditions. I'm gonna say if d is smaller than, like, let's say 20, we're gonna start by 20. If d is smaller than 20, then what gonna happen? Now I want to just create the wave sound. Okay, how I can create the wave sound? I can use my the win sound library that I imported above. So I'm gonna say win sound dot beep. Okay, so win sound dot beep is a built-in function in the win sound library. Okay, and I have to pass it two arguments. Okay, so what is these two arguments? The first argument, the wave sound that you want to, for example, play. And the second one is the time, that for how long you want to play that wave sound. Okay, so I'm gonna say, for example, for near distance, I mean for less than 220, I can say 2000. So 2000, what does this 2000 mean? 2000 hertz. Okay, it means that for the very close objects, because we are now in the condition that d is smaller than 20, it means that the object is very close. So I want to play like a 2000 hertz beep. And then I said the second argument is the time. Let's say, for example, for 80, but 80 what is the unit of the 80? The unit is millisecond. Okay, so I said for 2000 hertz. For how long? For 80 milliseconds. This is how we can just generate the wave sound. Okay, after that, let's just make a short pause, or it's a very tiny sleep. I'm gonna say time. Now you already know how to just make a sleep or tiny sleep in your program. You can use the time library. So I said time that sleep, very, very short. I'm gonna say, for example, oh sorry, I'm gonna say like 0.05. Okay, 0.05. Why I said this 0.05? this creates, a rapid, high-pitched, beeping urgent. Okay, so it means, that it means urgent. So it creates, a rapid, high-pitched beeping. Beep. It continuously, just, not continuously, just, make, the beep sound, very fast, too quickly. Okay. Now I can just repeat this action, 2, 3, or 4 times, or whatever you want. Depends, different distance that you want. Let's say, for example, for today project, let's, for example, define 3 more, distances. So I started with 20. Now I'm gonna use elif. I'm gonna say elif. Okay. Now if d smaller than, like, let's say 50 this time. So we started by 20, and now I'm gonna start by 50. So if elif d smaller than 50, then what gonna happen? Again, I'm gonna just use my win sound library dot beep, but this time I don't want to just beep very quickly. Just, let's, for example, instead of 2000, let's say 1500. So 1500 for how long? Again, but the time will be the same. Okay, 80. Now I just make a little bit longer, sleep. I'm gonna say time dot sleep. So this time, let's say 0.2. Okay, we will check. It's completely up to you guys. These numbers, you can just play with these numbers, to make, the desirable sound that you want. It's just completely up to you. I just for now I am just using them, and when we run the program, and if we see that it's a little bit, weird, we can just come back and change the numbers. Okay, so I said for 50, let's say now for example 70 or 80. So I'm gonna say elif. Sorry, I just made a mistake. Elif. So elif d smaller than 80, for example. Yes. So now this time I want, instead of 1500, now I'm gonna say win sound that beep. So this time, let's say 1000. Okay, 1000 for how long? For, instead of 80, let's say 60. Okay, because we don't, because 80 is just little bit far, so we don't need to just warn urgently. And now I'm gonna say time dot sleep for how long? For like 0.5. Okay, and the last one. Okay, so if for example we said 20, 50, 80, and now this time I'm gonna say else. Okay, so I don't pass it any distance. I just said else. Else, I don't want to make any sound. Now I'm gonna say time dot sleep for how long? For like 0.1. This is how I can use the win sound library, and how I can just generate the wave sound, with this function, with this sound worker. Okay. So now only just one thing left. We have to just create our threading. Okay, so how I can start my threading? I'm gonna use my library. Okay, the library that I imported above. Let me show you the threading library that I imported now. So I have to use it now. Let's just but we have to just don't create we don't have to create we don't I mean we shouldn't just create it inside of the the function. Okay, just start it outside of the function. Be very careful, because it's so far, here we were inside of the function, but you have to just start your threading outside of the function, because it's not part of your sound worker function, or win sound library. It's a completely separate library, so you have to start it outside of the function. Be careful, guys. So in order to start it, I can, after the function, I can come down. I can just come to the next line, and I can say, first of all, let's just call the library. So the library name was threading. Okay, so threading, and in order to start it, I'm gonna say threading dot Now, with the capital T, so thread. Okay, you know how we can do that? If you can remember, we did almost the same thing with this serial. See, when we imported the serial library, in order to just start it here, we said serial dot the next serial with a capital S. So we do the same thing here. We said threading dot thread. Now we're gonna open a parenthesis. Okay, so what we should do now? We have to just pass it, where we want to use this threading. We want to use this threading for this function, for the sound worker function. So our target for the threading is the sound worker function. I can say target. Okay, so target will equal to, now I'm gonna pass it the name of the function. So sound worker. Okay, sound worker. And just one more thing. The one more thing that we have to say here, we have to say, daemon, sorry, daemon, it's true, daemon, yes. So daemon will pass it true. Okay, true. So daemon, so daemon thread, it means that the thread will automatically exit when the main program ends. So we don't have to manually stop it. Okay, so in order to just make this threading completely automatically, when I mean the main loop, when we exit from the main loop, so in order to just exit from the threading as well, we have to use this diamond as, and we just give it true, we pass it true. So we said diamond true, and at the end, how we can start it? I can say dot start, open and close parentheses. So this is how we can just start and how we can create, our threading effect, our threading, and this is how we can use our threading library. Okay, so we don't need to do anything else here, guys. So we created our sound worker function and we just started our threading. After that, let's just go to our main loop, our while loop. And here the only thing that we have to do, we have to update, our sound input, because we don't want to use the raw, readings. We want to just, use the filtered readings, filtered distance data. So in order to do that, we have to update that current distance, the variable that we created, in our parameter section. So in order to do that, after we create this, the average distance, after here, see the AVG distance. Now we can just update our variable. So I'm gonna say current distance will equal to AVG distance, average distance. Okay, that's all. So what did we do here? With this line here, see guys, with updating this variable, after we compute the moving average, this average distance, AVG distance, we assign it to current distance. That's the variable the sound thread reads. So the beeps are based on the smooth filtered distance, not, as I told you, the raw reading. This avoids, the spurious, beeps from noise. So that's all. Everything else, tracking, plotting, sweep lines, all other things, they stay, exactly the same as in lesson number 6. Okay, we don't need to change anything else here, guys. Just let's go and run the program and see what's gonna happen. So I press the run button. Oh, it just show us an error, guys. Let's see. It says thread in it got an unexpected key. Oh, I think I made a mistake again. Daemon, it should be diamond. So DAEMON. Each time I just I use this function, I make the same mistake. And if you can remember, when I wanted to type it down, I made I was so careful to not make mistake, but again I made the same mistake. Okay, so let me just press the run button one more time and see what's gonna happen. Oh, see guys, so this is perfect. This time it's working perfectly. Let me just make it a little bit bigger so you can see everything clearly. See guys, so now can you hear the sound, the beep sound, the warning sound? So I will keep quiet so you can hear the sound properly. See guys, can you see, can you hear? And at the same time just see our LED matrix. Don't just think that it's not working correctly, because I put some different kind of objects in different distance. For example, now see here, now I put something in almost 49 centimeter away from the sensor, and now it's just it went away. So now again, this time let me show you one more time from here. See, from here there's an object in almost 8 centimeter away from sensor. That's perfect guys. Let me just make my hand near to the sensor. We're gonna see the sound, and I will keep quiet so you can hear the beep sound, and let's see if it's working correctly. Perfect guys, can you see, can you hear? See the beep, and now check the LED, it's blinking. Now I take away my hand. See, now you can see the sound is changing. See, and also the LED, our matrix LED. See, let me just try it one more time with my hand. You can hear guys, that's perfect. That's working perfectly guys. So our audible warning is also perfectly, everything just works the way that we want. And as you can see, our radar scope, our audible warning, and also our visual warning, everything's working perfectly. Just let's try one more time. I'm gonna just approach my hand to the sensor. Just I will keep quiet, you listen to the beep sound. Perfect guys. Yes, see. Okay, thankfully it's working perfectly, and we don't have any problem. Just I think today's lesson was not that difficult. We just added a function, and we added two new libraries. So now you became familiar with two new libraries, and why we have to just use those two libraries. But be careful guys, one more time let me tell you, if you're working only on Windows, so this library, this WinSound library, is working properly without any problem. But if you have Linux, or if you have like the MacBook or something like that, you just have to use another ways. You should just try another method, but don't worry, I will let you know. But for today, I don't tell you what can you do, because you have to use Pygame or something like that. So I don't want you to get confused, so I won't tell you now. Maybe in future lessons I will let you know about this. So hope you liked today's lesson, and hope everything is clear. Please just let me know if you have any doubt, or if you have any question regarding the lesson, or regarding the code, or whatever you want. See you in the next lesson.